Thank you very much. So you guys enjoying the conference so far?
Yeah.
Awesome. I don't know if we need to talk like a pirate day again. So my name is Michael Wood, and you can tell from my funny accent that I am nowhere from around here. I'm actually flown over from the States. Also, a reason for me to go later in the day is back home, the people are actually just now getting to work, and so there's actual chance that they might actually be watching me at this point. So over the last day, yesterday and today, you have heard a lot from a lot of very smart people, and now unfortunately you have to listen to me. But when we get down to it, a lot of what we've said has been reiterated in a lot of the different presentations. Unfortunately, everyone covered everything I had to say, so thank you very much. Actually, no. So I don't know how popular it is over here, but over in the States, there's a show called Mythbusters. Is it popular here? Excellent. So I don't have to explain who this gentleman is. Adam Savage is quoted in saying that failure is always an option. And his approach is mainly from the standpoint of science, right? He's doing a scientific or roughly scientific experiment, and he's trying to prove a point. And when he gets his results, it doesn't matter if the experiment actually failed or not. He learns something from those results. And when we're dealing with cloud development, or actually any development, a lot of what I'm going to say here is it can be used on premises or actually in the cloud. It doesn't matter. It's learning from your mistakes, but more importantly, learning from other people's mistakes. So at the end of this presentation, what I really want you to walk out of here with is a set of things that you can think about to say, how can my solution be better, right? So when we're thinking about failure in the cloud, we want things to be like have protection from certain things. So what are some things that we want protection from? Hardware failures, right? The little gerbils and machines run around. Every once in a while they get tired, they stop working, NIC cards go bad, etc. Now, in a cloud platform, especially like Windows Azure, we're set on something that actually has health built into the system. The platform is self-healing. It'll automatically detect when there are issues and try to correct them, whether that's rebooting the box or sending a message for another VM to be created and your code to be transitioned to it. But hardware is primarily taken care of for us by the platform. So what else do we need to protect from? Data corruption, or just data loss in general, right? So we need to make sure we have backups. We have to understand what happens when there's an actual large-scale problem, as well as just general, hey, we need this data that somebody accidentally deleted. A couple other things, network failure. Now, internally, or in data centers, for like if you have your own data center, it's very rare that you get a lot of network failure. Now, when you're talking about a cloud provider where you're going out and touching some data center, it's on the other side of the world or on the other side of the country, there's a lot of different hardware that you go through to get there, right? So there's a lot more possibility that network failures can occur, a lot more latency. I read an article maybe about a year or two ago where some lady was digging in her backyard and completely cut off internet connection to an entire country, right? I mean, she just dug through and all of a sudden no internet access for the neighboring country, which I'm sure they learned from and put in a redundant circuit. So. And then, of course, you have the most fearsome worry that we all have, and that's the impending Daikaiju attack. Now, this is Godzilla if you're not familiar with him. I used to have like a meteor. The whole idea of a meteor could take out the data center, but a couple of months ago that came a little too real. So we moved to something a little bit more fanciful. Now, all of these problems that we've talked about, I think the one that we're going to come into contact most often, the things we need to protect ourselves most from, is human error, right? A lot of times, outages occurred because someone chose the wrong thing, right? One particular one was somebody updated a configuration file and pushed that configuration file out, and that caused a significant failure and a significant outage for a cloud provider. There was an option for them to have pushed it out via an automated script, right? That would have handled the configuration correctly. So you've got to be careful with these things and understand that human error is going to be involved. And because of that, fall back to failure is always an option, right? It's going to happen. So don't think that whatever you put together is going to be perfect. Expect there to be failure. Matter of fact, start thinking about ways that it can fail. So while the title of this presentation is called Dependable Cloud Architecture, I'm really going to talk about it from the standpoint of resilience. Now, earlier in the year, myself and another gentleman from Microsoft named Brent Steinman put together a 4-hour workshop specifically about this. And so I'm going to talk really, really fast for the next 50 minutes to try to cram it all in. No, I won't do that to you. So we've distilled it down quite a bit. But the main things that I want to touch on today are monitoring and resilient solutions themselves, because they both have aspects when you want a dependable architecture. Now, before I really get started, I want to touch on this. And it's kind of been brought up before, but your stomach for cost versus risk is going to be different than someone else's. So the company you work for is going to make a decision at some point about how much cost they're willing to put out and to alleviate certain risks, right? And throughout my career, I have worked for clients who their website was nothing more than a phone number to their receptionist. So if their website was down for a day, they didn't care, right? It's like, okay, whatever, that's fine. And I've also worked with clients that if their website went down for minutes, they could lose thousands or hundreds of thousands of dollars, right? So their gut feel for how much risk they're willing to take was fairly low. So they're willing to throw out more money at it. So without panicking anybody in the room, as I go through today, I will talk about different aspects of things that you can think about. Should we be doing this or should we be doing that? Some of you in the room will say, okay, that doesn't go far enough. You really need to think about these other things as well. And then some people will be of the mind that, okay, that's way too much. I don't want to do that much effort. And that's just a risk versus cost decision. But in the end, a lot of times we talk about uptime in numbers, right? 99.95 or 3 nines or 4 nines. I just want you to understand that the more nines you want here, the more zeros you're going to add over here. Okay, it's a pretty simple equation. But in the end, that's not a cloud thing. You have that same scenario in any on-premises situation as well, right? So let's start with monitoring. If you put together presentations, NASA has a whole bunch of art that you can just go get, and it's free to use. It's awesome. So you'll see a lot of NASA shots in here. Now, how many people in the room, I know there was a similar poll yesterday, but almost everybody raised their hand when the question was asked how many people have activated their MSDN. Now, I want to know is how many people have production systems running in Azure? Okay, decent number. So how many people are monitoring those? Okay. How many people are science fiction fans? Completely different question. All right, so almost everybody's hand in the room went up. This is not surprising. Yes. So I usually follow that up with who got drugged here by the person sitting next to him that didn't raise their hand. So if you've been in science fiction or you've read science fiction or watched a science fiction movie, you will have probably seen something where someone gets injured, they get brought into a room, a holographic image is superimposed over the body, and all of a sudden these little things start, oh, this is where his arm is broken, this is where he needs help, etc. Wouldn't it be awesome if we had that capability? Wouldn't it be awesome if our bodies were constantly spewing out information that a doctor could look at and then start analyzing and saying, you know what? This isn't good because if he keeps going in this route, he's going to have a heart attack, right? Mike needs to calm down and not rush through things. So I wear a Fitbit, which is a little fancy pedometer, right? Keeps track of how many steps I take a day, how many floors, how many stair flights I take, etc. But if I could take that information, gather up other information such as heart rate during the same period, blood pressure during the same period, etc., I could get a pretty good baseline of what it's like to be me on any given day, right? And then a doctor could look at that and say, this is going good, this is going bad, here's where you need to improve, this is when you were speaking or stressed, right? So we can do the same things with our applications, and a couple people have already mentioned it, and we really should be doing it. So how do you monitor your applications currently? Anybody?
My site's down. I know it's a problem.
The site's down, you just know there's a problem. Anyone else? Come on. Management portal. How about just solutions in general? I'll get to that. Diagnostics? Okay. SCOM. So logging messages, I didn't actually hear, which is almost the number one things that I've heard in other times that I've talked about this. People say, well, we write logging messages. And one of my first questions for that is, do you read them? Or do you wait for the one that comes across that has the big error exclamation point on it, right? So hardware health, right? Again, looking back at Windows Azure and other cloud platforms, they have self-healing mechanisms. So you don't have to worry about this as much, but you should probably know when things are actually moving around inside of Azure. When a machine is, maybe there's nothing wrong with it, maybe it's just having its guest OS updated or its host OS updated, and it will cycle down, get updated, and cycle back up. Knowing this about your systems and the platform you're sitting on can help you get a good idea of how things are going. The dashboard is not accurate sometimes was the statement. Yeah. So gathering your own statistics as a way to not only pay attention to what's actually going on, if you're logging correctly, right? But then also compare that to what other data sources are telling you to try to pick out anomalies. Something that we're constantly starting to see more and more of is the use of dependent services. So there are reaching out, I'm going to use table storage, or I'm going to use Facebook or Twitter. These are dependent services that you've taken on as a dependency in your system. So how do you know if they're up? A great point was made in a series I'll point out later. But what's the SLA for Facebook authentication? Does anybody know? I don't know if there really is one, right? Now, obviously, it's in their best interest to keep it up, keep it running, keep it smooth, because not only do all the people that have taken on that API and they're starting to use Facebook as authentication, but they also have their own system based on it, right? So they're incentive to keep that up. But is there an SLA or not?
Well, they don't need one. It's always up.
It's always up. The statement is they don't need one, it's always up. So while it's not necessarily a bad thing to choose it, I'm definitely not saying that. It's very good to choose it. But make sure you are taking an educated decision, right? Look at the service. What is its uptimes? What's its SLA? What are other people saying about it? And base your decisions off that. So as all this data flows in, it's all called telemetry, right? It's all big data, as long as you have more than one running, right? So if you've got tons of instances out there running, you're collecting a tremendous amount of data, and you need to be paying attention to it and looking at it. Now, there's a lot of different ways you can do this. You can do it through log messages, through Azure Diagnostics, which was mentioned when I asked for feedback. You can do it with things like New Relic and monitor your systems that way. There's also a product called Azure Watch out there that monitors your systems in Windows Azure, pays attention to what's going on. Those are all good things to take a look at. But the big point here is pay attention to what your applications are doing. Now, the screenshot here is a little older, but this is from Sarah Brada's Diagnostics Manager, which that feature has been rolled into their Azure Management Studio. But it can go out to the Azure Diagnostics tables and give you a view into what's going on. This is a chart for the CPUs, I believe CPU, for a couple of roles, right? This allows you to analyze the information, and that's really what you need to do with this data. As you're monitoring your systems, I would recommend that you have at least 2 channels of information. One is the giant exclamation point, right? There's a big problem, somebody needs to be looking at this immediately, right? And have that high on your list, have the features of your system or solutions that should trigger that tagged, people paying attention to it. then all of the other data, like are machines going up and down, are they scaling up and down correctly, what's your average throughput on your messages, etc. All that other data needs to be gathered and analyzed. I'll give you an example. So I used to work for a company called Cumulux, which was recently bought out by Aditi. But when I worked for Cumulux, they had a product, and this product was monitoring Azure. And the product team specifically decided we're going to dog food this. So the watcher was watching the watcher, right? So they're just keeping track of how it's working. And at one point, one of the developers said, the memory utilization on these worker roles are a little higher than I remember them being. Not like it wasn't, completely maxed out on the box. It wasn't causing a performance problem per se. But he looked at it and said, this is a little bit more than I remember. When he went back through the logs, because they were collecting this history, he identified the release that caused the problem. They dug down into some code and figured out, oh, we're not efficiently doing something with this code right here. And they corrected it. Having a good baseline of what your solutions should look like allows you to pick out when things are not correct. So keep that in mind. And I know Martin's definitely talked about logging yesterday in the MyGet session where he said they could have used a lot more logging. And that's a great thing. A lot of people don't think about it up front. What do I need to actually know about the code at this point to know that it's working correctly or that I can see how well it is working? So resilient systems. When you talk about resiliency, you're talking about being able to bounce back, right? It can come right back from any sort of problem, or most problems anyway, right? And remember, failure is always an option. We talked about some of the failure points already that you could see, but a couple of more that have also been mentioned throughout the other sessions is throttling. Not only if you are accepting calls in, you may have to throttle so that you're not overwhelmed as you spin up more instances or deal with that. But also when you're calling out the third-party dependencies, you may get throttled. And what does that mean for you to be able to finish your processing or answer your users? And again, the external service dependencies. These, if you look at them, right, except for the actual machine crash here, these are all software-based. We have spent too much time over the last umpteen years or decades worrying about hardware being the uptime issue, right? I want you to have duplicate power supplies and duplicate NICs and et cetera, because I want the hardware up. But what that's done is the same amount of pressure was not put on developers, right, to ensure that their apps could be up all the time. How many people have written this code? Well, not exactly this code, but close enough, right? Right? No one raised their hand? I'm feeling very, very bad at this point. Okay. All right. So this is not resilient code. First of all, try-catch does not equal resilience, right? Especially because nothing happens to this point, right? Try-catch, and I'm doing what Magnus said don't do, which is use the laser pointer on the screen. So when you have a try-catch, so you're looking at this try-catch, I don't do anything except log the fact that, yeah, I couldn't create that, right? And then I throw it out for somebody else to explode up the tree, right? That's not very resilient. The other thing that I'm doing here is I'm hard coding what file I want created. This is not resilient. It's not resilient because, A, what happens if I can't write to that file? The only error I'm actually trapping here is that the directory wasn't there. What if I can't write to it? I don't have permissions. What if the file's already there and it won't allow me to overwrite? Somebody's got it locked. There's all sorts of things that could go wrong with this. And in the end, what I have to do is take a step back and say, what's the larger picture here? I want a file to be created. So what could go wrong with creating that file? Well, maybe I can't put it where I want it. Maybe the directory isn't there. Maybe your code should be handling that, right? So instead, we've been talking about the transient fault handling, right, the retries. So instead of just try, fail, and let that pass up the system, perhaps the code should check, can I write to that directory? Can I create that file there? And if so, do so, right? Or maybe, for efficiency's sake, you just try it, and if it fails, figure out why, and correct it in the code. Don't just bounce it out, because the user then just gets a bad experience. Now, there will be cases, of course, that you can't handle, and that's fine, right? And even if you have self-correcting code, self-healing code, doesn't mean you shouldn't be logging that scenario. So, for example, if I'm constantly in my log seeing directory not found, directory not found, directory not found, and I'm creating it somewhere else, then that's a problem. I should go correct that, right? So my family is huge in Legos, right? We love Legos. This is actually a kit that my wife has, right? That my parents bought her for Christmas. But Legos are the epitome of decomposition, right? You can go from really bitty pieces up to massive models, right? The other thing they're really good about is componentization. Has anybody built a Lego model recently? Right? Awesome, right? More people raise their hand than those that log. I just want to point that out. So when you pull out the Legos, right, they have the great instructions. You put them together, and then you have a piece over here, and then you put this other piece together over here, and then they snap together to make something larger, right? You're componentizing. You're decomposing the systems. Don't have monolithic systems, right? And this was also brought up yesterday multiple times. When you have a monolithic system, or if you have a website and it does all your processing, everything, you're stuck. It scales at that level. You have to put out a large one of those every time you want it to move up, right? So decompose the system. Start introducing messaging, which was brought up in several of the presentations, right? Start introducing a lot of different ways to just break down the system so that A, you can scale them differently, B, you can deal with failures in each individual component rather than the whole thing. There's a lot of good use that you will get out of decomposing your system. Now, a lot of people, especially developers, when they look at decomposing their systems, they will immediately key in on, well, I'm going to pass a message from the website back here to the backend processor to do ordering, right? So an order comes in, we throw it on the message, he pulls it off, he does the work. That's fine. But that's a technological distinction, right? Also take a time to think about how the business sees your environment and your solution. Does the business see payroll as something that they outsource? If they do, then you in your mind need to treat that as a separate component in your system and not marry it up too heavily with all the rest of your stuff. Because if you do have to pull that off and send it to someone else, you want that to be a fairly clean, easy, maintainable interface, right? So keep that in mind. Now, as we're talking about scaling up, right, in the cloud, there's a couple of different things that you're going to run into. Now, a couple of patterns, they're not really patterns, but some things I'm going to talk about over the next couple of slides are things for you to think about, but I'm not going to get down deep in the details of how they work. I just want to give you a high level of things to keep in mind. Now, I don't know how common these are over here, but in the States, you'll see water towers everywhere, right? Every little town in the Midwest has one. And the reason why is twofold. One, when you live in a very flat area, right, then water pressure just isn't all that good. So by putting the water up high, that adds pressure to the system, right? And two, it's all about capacity buffering. So if everybody, I grew up in a really tiny town, really tiny town. There are probably more people in this room than lived in my town. Well, not that small. But if all of them went to their house and turned on their spigots at the exact same time, and we didn't have a water tower, what do you think would happen? Right? We don't have pipes the size of trucks like they do in giant cities. We have very small water mains. The pressure would drop tremendously in the system and it would just trickle out. People would have a hard time getting water. Because there's a water tower, they build up capacity that can handle that spike in load. So how can we do that technologically? Well, we can do it with a CDN. We have a lot of static data that's sitting out there. Not only is it scattered out across the globe so that people can get to it, or as was pointed out yesterday, get to the fastest one, not necessarily the closest one. But that data is there and it can be served up by a whole bunch of machines rather than just one or two web servers, right? Distributed application cache. If we have information that needs to be shared across sessions or information that we can load up and just be ready to hand out as soon as somebody asks for it, that relieves stress off of our finite resources like our databases, right? And then local content cache. So if you have something that's every time or the majority of the time you're going to be asking for and it doesn't change per session or per user or anything like that, get a cache set up locally on the boxes on your web servers to just be able to grab that information right then and do something with it. And don't think of this just as, you know, HTTP web server stuff. If you have processing that you do on worker roles and it's constantly going and getting the same data as part of its process, why not cache it? Speed that up. Reduce pressure on your actual finite resources, meaning your database and those things, and provide some buffering and capacity so when you have those spikes you can deal with it. Yeah. So it's easily recovered from outages and spikes in load. And along with that line, talking about carrying extra capacity. Now, you can put this model in your head as spread across 2 different data centers, spread across 2 different providers, or just 2 different cloud services in the same data center. However you want to model it in your head, just carry spare capacity, right? Think about any one of your workloads and say, do I need to carry spare? So if you're looking at it this way and you say, well, if I carry 50% more capacity than I actually need, then once we have a problem, I can react to that a lot faster, or the system won't completely fail, right? It may get sluggish, but if I fail over and then all of the load is coming onto the other nodes, then I can spin up more in the background, right? So think about carrying capacity. Degrade, don't fail. So I know we've been tweeting in here about the different stuff that we've been hearing. How many people have been on Twitter for more than, say, 4 years? Okay. You guys remember the fail whale? The fail whale? Yeah. So when you would go to Twitter, if it wasn't working, you would get a picture of a whale being carried by these little birds. And it would say something like, we're sorry, we know it's down, bear with us, that kind of stuff. But it became known as the fail whale. They gave their users an experience even though the system was failing, right? So think about the scenarios where you might degrade without failing. Now, following up request capacity buffering, which is where a bunch of people all at once are going to come and you can prep the information and just hand it out as fast as you can. When you talk about request buffering, it's a little different. This is when they arrive, they want something, and you can't have it prepped ahead of time, okay? So how many people have been to an amusement park, like a Disney World or something like that? Yeah. So I didn't take this shot, but this is from Disneyland or Disney World, and nobody does lines like Disney, right? They are great at moving people. They are also great at completely distracting you from the fact that you're standing in a line and have been for 45 minutes, okay? So when you get to the parks really early, you show up and you run up to a ride. The ride is very, very quick to get onto, right? Physically, there's not many people between you and the ride, and also distance-wise, right? You walk up, and it's almost like you get to the end of the ride, and you walk like 10 feet, and you're on the ride. 2.5 hours later, right, a bunch of people have come in. You get there, and somehow that 10.5 feet to get to the ride turns into this back and forth between all of the velvet ropes and the chains because they've extended it, right? So what they're doing is buffering up the requests. Everybody comes in, they buffer them all up, right? Technology-wise, we do this with queues, which is funny. In the States, we say a line, we stand in line. In Britain, they use queues, which makes a lot more sense to technical people. But that's what it is, right? They're buffering up the request. The other thing that we have talked about a lot is retry policies. Now, that may sound a little funny, right? Why you're buffering the request? Well, what I'm actually doing is just retrying the request, right? I haven't gone back to the person to ask for it to tell them, no, you can't have it, or it's blown up, or something like that. I just try it again a certain number of times. And retry policies, queues are great for when you can completely break apart the processing. Someone submits an order for a book, and they're not expecting an immediate, okay, I've been given the book, right? It's okay if it takes a little while. There's other scenarios where you show up and you're like, I'd like to know what book is out today. No, they want the answer right then, right? And that's where retry policies should come into play to make sure that you can at least try to give them that data as much as possible. And then async workloads. Now, some of you may be thinking asynchronous workloads, same thing as queues, and in truth, queues are a type of dealing with asynchronous workloads. But even in those scenarios where someone shows up and they're immediately expecting an answer, doesn't mean that we can't put an async operation into the middle of it. So if you're used to working with ASP.NET, you know that there's asynchronous page processing. So from the user standpoint, they have sent a request into the browser. From the resources standpoint on your box, you're processing that asynchronously, waiting on a database call to come back, waiting on some other information to come back, whatever. But the resources on that box are freed up. It allows you to have and serve a larger capacity, right? While still returning to them what appears to be a synchronous response, right? So keep these in mind as ways to deal with getting a lot of requests for something that is a finite resource. So moving on to redundancy. Now we're going to talk about redundancy. So this is probably the largest one that I get people saying, okay, that's gone way too far. I don't need to do that. But when you talk about redundancy, you have a lot of choices from the standpoint of your data, from the standpoint of your solutions, okay? So let's talk about from the standpoint of a solution. And by that, I mean the actual code, the deployment bits, right? You can try to, or decide to have a full hot capacity ready to go state sitting somewhere, whether that's in another provider, in another data center, or whatever, right? Or even fall back to on-premises. You have something that's completely scaled, same level as what your primary site is. So if there's any problem, you can flip over and start using that. As you can imagine, depending on what your actual solution and deployment footprint is, that could be pretty expensive or not, right? All depends on what you're doing. Now, you can also have what's called a warm backup. And what that means is it's not scaled all the way up. It's running. The machines are there. But if you need if there is a problem, you need to switch over, then it's got scripts to spin it up to the full capacity, right? So you're not worried about, okay, well, I've got to wait for this machine to actually come all the way online. No, it's online. You're just going to spin up more of them in the background. And then cold, right? I don't have anything deployed anywhere. And what I want to do is spin it up. A couple of things about this. One, whatever you do, this is perfectly okay decision. It all depends on what your scenario is. Don't let me make you think that all these things I'm about to say is bad. But whatever you do, if you decide to go this route, don't have a 28-page document that starts with create subscription, create namespace, upload database, right? That's not going to work. Number one, that's the time in which a tremendous amount of stress is put on everyone, right? And you will make a mistake. So it's better to have automated scripts to do that for you. Patrick showed us some scripts. We've seen from other people show you PowerShell scripts. All of that is what you need to be thinking about. How can I automate the recovery of these systems, right? So continuing on about redundancy, there's a point that I want to make, because in cloud computing, we're constantly talking about redundancy, right? That's how we get high availability, SLAs, redundancy, redundancy. So it's all about probability. That's why we talk about SLAs a lot of times in like percentages. So, whoops. So if we have a 95% uptime for whatever it is, that's 438 hours per year that it's possible to have downtime. Rough calculation is 18 and a half days, right? Is that acceptable to most of your businesses? Yeah. That was not as vehement as I usually get, so some in the room are like, yeah, that's fine. So now if we add a second box to that, again, these are two different boxes. They both have 95% uptime. I will point out that they do not have a single point of failure. They both don't go to the same database. Okay, these are completely isolated systems. If you do that, then the math, which I will say Brent did if it's wrong, and I will say that Brent did if it's right, because I'm horrible at math. But that gets down to 22 hours a year, right? Possibility. Now, if you ramp that all the way up to 4, right, you're down to 3.285 minutes a year, right? That's not a lot of time, right? Do you think that you have that level, right? Does anybody in the room have that level of uptime? No? When you start talking to your business about uptime and high availability about your systems, first of all, have the discussion about hardware. Second, have a discussion about quality code, which I've already talked about, to make sure that your systems themselves are self-healing, etc. But when you get to the actual, what's the expectations of this, keep this in mind. And Brent also brought this to the table. This is awesome. Because when someone looks at you and they just have read an article that talks about 3 nines, we should have 3 nines, we should be doing that, do the rough calculations of how much downtime a year that is, and then say, this is the process that we have to go through for any outage. So first of all, we have to detect it. For those of you who didn't raise your hand when I asked if you were monitoring your solutions, this will be bad. So back to what Martin said earlier, now you're finding out from Twitter that your system is down, right? That is not a valid input point. Or it's valid, trust me, but you should know it before that happens, right? So time to diagnose. Again, what's going on? If you're not monitoring your systems and know what's healthy and what isn't, then you're going to have a hard time diagnosing what the actual problem is. And that increases the length of your outage. Time to decide. Now this is the fun part, because this is sometimes, depending on the structure of your company, where you have to call the person who said they want 3 nines or 4 nines to make a decision about something, right? Do you think you can even explain to them what's going on in 3.285 minutes, right? Then after that decision is made, now you have to act. And in some cases, especially if you're dealing with giant data sets or large deployments, it's not fast to fix these things, right? It takes time to roll this stuff out. So keep all of that in mind when you're thinking about what your downtime is or what you should be targeting, right? And I will point it to you this way. Try not to think about percentages. Try not to approach it to be, we should be up, 99.999. It should be, how can our systems stay up even when there's problems? That's what you should concentrate on, right? One of the ways that you can do that is dealing with dynamic addressing and configuration. Somebody already pointed out the failures that we had in Azure on the client cert and also the SSL cert. There's other problems that have occurred in Amazon, and every one of the cloud providers have had small outages here and there, and some large. Some of them can be handled by the fact that if you build dynamic addressing and configuration into your systems, then you can flip and tell it to go somewhere else. Remember my really horrible try-catch code, right, with the hard-coded path? I'm stuck. That thing will always try to write to that one location. I should have had the ability to pass in, try this one. Oh, that didn't work. Well, then consumer of that code can go, that didn't work. Oh, here, try this one, right? Now try that one until it works, right? Or until you reach the max of saying, I can't try that anymore. This really should fail. But have that configuration be able to be sent out and updatable as much as possible. Now, with Windows Azure, you can do this with the cloud's the service configuration file. That's where you can go to the portal, upload a little bit, or use PowerShell to upload some changes to this configuration file, and then all your roles get this information. But how you handle that may be perfectly good for your solution, or may not be fast enough for your solution to react, right? Because when you upload that configuration change, what happens is Azure notifies your servers in groups so that they're not all down at the same time. It's the same thing it does when you do an update. And it tells them in groups, hey, here's a configuration change. Now, depending on how you've written your code to handle that, that may cause a recycle, maybe it doesn't. But at the same time, you've got to walk through those groups. That may be perfectly acceptable in your scenario. In some scenarios, you need it to be updating much, much faster than that. All depends on what you're doing. And in that case, you can't rely on that mechanism. You've got to be able to put in your own system to send out this configuration change and have your servers react to that. Again, risk versus cost, right? Data. This one is difficult, right? Especially if you deal with a data in any amount of size, right? The local storage, or excuse me, not the local storage, the storage accounts are great. And we've seen, Alan gave a great presentation here just a few minutes ago about how fast it is, how you can push data into it, get data out. But if you need that data somewhere else, if there's a failover mechanism, then you've got to deal with that, right? It's not impossible. It's just a little tricky, and you have to ask yourself questions like, how much data can I have missing? If I have to flip over, how much data can be missing? What's acceptable? Can I just have backups every day and be able to restore yesterday's backup and then lose from whatever happened from that backup? That's fine. Or maybe it has to be every 10 minutes or 15 minutes. These are the questions you have to ask yourself and then work around them. Now the GRS, the globally redundant storage, that's not right. It's not globally redundant. What's the geo-redundant storage? So, or geo-replicated storage. That's where in the accounts, the storage account, you can specifically say, I want this replicated to another subregion, so another data center in the same region. And that's awesome, right? That's great. At this point, you can't flip the switch to tell it to go to that other set, right? So it's a great mechanism. It's great for recovery for Microsoft and for you in dire loss of data center Daikaiju attack kind of scenarios, right? But if you need it to be a little faster, if you need control over it, then you have to put that in place on your own. So data is probably the trickiest thing when you're talking about having your own solutions to self-heal and be able to flip over to something else, because the code is just code, right? It's just deploy the bits, right? Yes, sir.
And the greatest risk of data loss is human error.
Yes, so the observation is the greatest risk of data loss is human error. Yep. There's a slide that Brian Prince from Microsoft put together a long time ago about things you should be worried about with your data, and one of them was Bob the SQL builder, right? The person that goes in and says, update table, blah, 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 and completely forgets a where clause, right? Yeah, it never happens. Yeah. So again, let's talk real quick about availability versus degradation. So this shot, I always have to brag on this, but this shot is actually not from NASA. I took that. That's the Endeavor's last launch. It was the second to last shuttle to go up, and thank you, NASA Tweet Up, for having me out. That was awesome. But while I was there, I heard a really cool story about the shuttles, and then I told this story at CodeMash, and an attendee came to me afterwards and elaborated on it and made it even better. So on the shuttle, it's all about redundancy, right? The Apollo program, when we sent people to the moon, we spent more about quality. Everything was down to the it's just tremendous amount of effort and cost put into making sure that every little piece did what it was supposed to do. The shuttle, they backed away from that and said, we have to constantly reuse these things, so we need to have composable parts that we can swap out when things go bad, between missions, etc., and we need to have redundancy for them when they're in the air. So they bought 5 IBM general purpose computers to put in the shuttle. 4 of them they put in lockstep execution. So basically all 4 machines are executing the same line of code at the exact same time, and then they look at the answers. And if they're all in agreement, awesome. If 3 of them are in agreement, good enough, right? And if one of them goes down, that's okay, right? Because you still have that quorum. So that was the story I had told about redundancy and an example of it in technology. And then after my session at CodeMash, this gentleman came up to me and said, you need to read about the incident that occurred in the simulator that dealt with this. And I said, okay. So I went out and I did some research. Turns out there was a scrubbed launch where something went wrong with a component. They detect these things. They can basically cut off launch until they ignited the 2 solid rocket boosters on either side. So, and then as it was put to me, it's going somewhere after those are lit. So what happened was they got into the simulator and they were practicing what's called a transatlantic abort. So when it launches, it comes up off Florida and it arcs upside down up over the Atlantic Ocean. And you reach a point of no return. At that point, it's got to go into space. But prior to that point, if something is having a significant problem, they can abort, which means they drop the rocket, solid rocket boosters, they drop the fuel tank, and then they rotate the orbiter and they land it in Europe, right? I don't think it ever actually had to happen, but in the simulator, they were practicing this. And if you've ever been on an airplane that has to turn around and land when it didn't expect, I think there are a few people in the room that had that issue, or God forbid you were actually in an emergency and planes, they will dump their fuel before they land, right? So in this particular case, that's when they had to dump the fuel. So they flipped the switch to dump the fuel, and up came a big red X on all the main computer screens, right? That was the equivalent of a blue screen, right? Needless to say, the astronauts not too happy with this, right? What happened was all 4 of these computers executing the same line of code lockstep, they all hit a null reference pointer. Ow is correct, right? So redundancy, now most of our systems are not in lockstep like that, right? But if the bug is there and you've got it spread across, you're going to hit it, right? All of them are going to hit it. So to talk about degradation instead of failure. Now this may or may not have been the case. I couldn't find out by doing the research. I couldn't find out if this was the case or not. But remember I said there were 5 computers on the shuttle, right? Not 4. That 5th one had code written by a completely different vendor and only dealt with landing and takeoff, right? So it had a degraded performance set of what it could do, but at the same time, the users didn't experience complete failure, right? So think about that in your own systems. How can you fail over to something? Netflix does it. If you've ever gone on the Netflix and you're looking for these are recommended for you, and it's taking a while to come back, well, if they can't get it fast enough, they'll simply give you a list of really popular things to watch, right? I mean, if you're like most people, you go, oh, okay, that's cool. You don't even know, right? So what kind of experience can you give your users without failing? If you can't reach the database, I don't know, show them Pac-Man or something. But the idea is find something that's useful to them without completely failing, right? And one of the ways that we can do things like that is through automation, right? And I've talked about this quite a bit throughout the presentation. Having scripts, knowing how to deal with things. Virtualization, without virtualization, the cloud would not really be possible, right? That's just way too much hardware, way too much cost and expense. We would have data centers the size of Stockholm itself just to run what's equivalent to one of the data centers we have now. So virtualization makes it possible. Individual IT pros don't scale when you're talking about hundreds of thousands of machines, right? So in order to deal with that, they just automate stuff, right? They're smart guys and girls. They figure it out. They write scripts to do the automation. So make sure in your own systems as you're improving your code, right, and the self-healing abilities of your own code, make sure that you're also working with the IT pros, if you're not in a DevOps shop, to make sure that they have scripts that can bring you up somewhere else, that can recover from scenarios, rechange configuration. Never, ever, ever make it in your process in which someone is manually typing into a configuration field and pushing it to production, right? You should have the set of things that you will be setting it to or possible to set it to, and a script to apply those, right? And then you should test these scripts. Don't wait until the system is down to go, well, this will be fun to see if it works. Click, right? And be very, very careful how intelligent you make these scripts, right? You do not want to make them into the next Skynet, which for those of you in the room that aren't familiar with that is the self-aware computer from Terminator that pretty much wanted to wipe out mankind. No one really wants to be blamed for one of these, so my suggestion is make sure you put in what's called a high point. Now somebody pointed out earlier about the failure with the certificate, right? The leap day certificate. Part of the issue that happened was Windows Azure was doing its self-healing mechanism, and it was pushing this thing out. And when it would cause this node to fail, it would move it off to another node. And then that node would fail, and it kept going. And the guys at Microsoft, being very bright, put in a high point, human intervention. At some point, the machine went, okay, I'm really messing things up. Everything I know to do to fix this is breaking everything more. So I'm going to stop and let humans make decisions at this point. So especially for your auto-scaling, put in a high point, right? So in addition to Legos, my family is also heavily into NASA. Couldn't tell at all, yes. So this, if you're not familiar with it, is an artist rendering of the landing of the Curiosity rover on Mars. If you haven't watched the technological wonder that this actually was, go out and search for a video called 7 Minutes of Terror that NASA put together that talks about this landing. and how technically difficult it actually was. They couldn't test all of this at the same time. They could only test bits and pieces of it, and they certainly couldn't test it in the atmospheric conditions of Mars, right? So the first time it ran was when it landed, right? When they went through this process, and every project that NASA does, they sit around and think about how things can go wrong. And my point here is, how many people in this room code the happy path, put a try-catch in, and move on, right? Now, there's some honest people in the room. I appreciate that. So think about that. And in your solutions, you need to be thinking about what can go wrong. What happens if I lose connection to my database? What happens if I lose connection to this? How does the system react to that? I worked at a company that had a developer that had a really good panache in testing. Loved to test. And he called some people over on a project. I wasn't there. I wasn't part of the project. I could hear this laughter from across the room. I had to go find out what it was. But apparently he had brought them over and he was showing them this, ugly ASP.NET yellow screen of death. He's like, your system is failing. And they're like, okay, show me what you did. He's like, okay. So he plugs some stuff around and he hits a button and it's making a call to the database. He reaches over, of course, all the test systems are right next to his desk. He reaches over and pulls the network cable out of the wall from the database. And they're like, whoa, you can't do that. And he's like, it can go bad, right? Now his point was he didn't expect data to appear on the screen, but he certainly expected something other than this big giant error message that gave them no help, right? So think about your solutions, concentrate heavily on what can go wrong, and then think about, how do I mitigate that? And you may come down to that risk versus cost scenario where you're like, yeah, we can mitigate that, but we need to put it up in a whole other data center and have this issue and this issue. But that's a conscious decision, and that's completely fine. There were several decisions made in this NASA project that basically said, if we can't deal with that, or if that happens, $2.5 billion. Okay? But that's fine, right? Because they made a conscious decision. Because failure is always an option. Thank you, Magnus. So in summary, some things I'd like to leave you with. We all like to think that what we put together is awesome until we look at it 3 or 4 months later and then we go, ooh, yeah, that's before I knew better. We'll do it this way this time, right? So think about your solutions. What I do want you to do is look at root cause analysis. When you have a problem, dig down. Martin yesterday was talking about this with MyGit, the fact that he did a root cause analysis. Awesome. Do that. And when you have, and if you're working with a solution in which you have end users that are turning around using your API or using your system, publish out and say, this is what went wrong. Here's what we're going to do to try to solve that in the future. And possibly, if you do these things with your designs, even if we have it happen again, it won't be an issue, right? Now, you're not going to make all the mistakes. There's no way you have enough time to make all the mistakes. So learn from other people's mistakes. Go and read the root cause analysis from anything, from anybody, whether it's on another platform, doesn't matter. I don't know how many people I heard laugh and joke about the leap day bug. They're like, oh, they can't develop things that can do math. And my thought was, did you go look at your own code to see if you have the same issue? Because you might, or you might have something equally as not smart, right? Everybody makes mistakes. Failure is always an option, and the human factor means that eventually something's going to get in there. So anytime you see any sort of failure, learn from it. Again, admit that everything can go wrong at some point. And this was something that was talked about a little bit before during the break. Don't get cocky, right? Just because something hasn't failed doesn't mean it won't. I always find it amusing between the providers, when one of them has outages, they all make fun of the other one. It's back and forth. It's like, seriously? That's going to be you next week, right? So, and definitely do not stick your head in the sand. Don't take the approach of the happy path is just going to be okay. And even if it means you're telling the business, these are the things that can go wrong, here's how we can mitigate them, do you want me to take this decision or not? Do you want me to take this forward? Do you want me to implement this solution? Have those discussions and make sure that they just have educated decisions, right? Because I guarantee you, they don't know what can go wrong, right? And with that, first of all, I want to thank Magnus and Alan for having me over. I really, really appreciate the opportunity. And this has been an awesome conference. If you've got questions for me, you can reach out. This is my, not my email address, but that's my blog address. My email address is really hard to remember. It's the same thing at mvwood.com. So it's mvwood at mvwood.com. If you want like 2 days worth of content of covering a lot of what I just talked about in much more detail and a lot better information, go out to this bit.ly address, which is Cloud Failsafe. That is the Failsafe series that was put together by Microsoft, by their Azure Cat team and MCS. And it's a wealth of information by people who have put together systems that are far larger than anything I've ever looked at. Okay? So again, thank you all very much.